The given equation is limitation of x over square root of x squared plus 9 as x approaches positive infinity. Direct substitution will not work in this function because x is approaching positive infinity. In this case, we need to factor the highest degree term out of radicand, which is x squared. Transfer out the x squared using parentheses and separate to the number 9. The reason why there is 1, when we multiply x squared into 1, it is equal to x squared. And then, if we multiply x squared into 9 and over it by x squared, the answer will be 9. So this is the factor of square root of x squared plus 9. X squared multiplied by 1 plus 9 over x squared. Since they're already separated, we can also separate the square root. So square root of x squared multiplied by square root of 1 plus 9 over x squared. We all know that the square root of x squared is x, so we can just write x to the equation. Therefore, the new equation is the limitation of x over x multiplied by 9 over x squared as x approaches positive infinity. At this point, we have like terms, so we can just cancel it out. The result will be 1 over 1 plus 9 over x squared. According to limit at infinity theorem number 2, it is stated that limitation of k over x rise to n as x approaches positive infinity is equal to 0. Therefore, we conclude that limitation of 9 over x squared as x approaches positive infinity is also equal to 0. So, if we apply it to the equation will be limitation of 1 over square root of 1 plus 0 as x approaches positive infinity. The square root of 1 plus 0 is equal to 1. So it will be 1 over square root of 1. The square root of 1 is 1. So 1 over 1 is equal to 1. The answer will be the limitation of x over square root of x squared plus 9 is equal to 1.
Now, let's move on to another function. As you can see, if we directly substitute the approaching value of x, we will get the answer of 0 over 0. In evaluating the limit, if we get 0 over 0 or infinity over infinity, we called it indeterminate because they do not have a fixed or predictable value on their own. In this case, we can use the L'Hopital's rule. It states that the limitation of f of x over g of x as x approaches to a number is equal to the limitation of f prime of x over g prime of x as x approaches to a number. It is simply getting the derivatives of the function. Now that we get the derivatives, we can write the function and we can also substitute the approaching value of x. So there's we call the power rule that anything raised to 0, the answer is 1. Now we can replace e raised to 0 as 1. And then we have 3 multiplied by 1 in the numerator and 1 in the denominator. And that's it. 3 over 1 is equals to 3. Now we knew that the limit of e raised to 3 times x minus 1 over e raised to x minus 1 as x approaches to 0 is 3. That's the end of our tutorial and I hope you learned something. Thank you for watching!